Alright, good morning guys. Today we're going to be covering Notes 2.08, and this is actually the last lesson before the review, and then after the review we're going to have the test. And so over the past couple of weeks we've learned how to factor binomials and trinomials, and today we're going to put everything that we've learned together and kind of outline some steps to make sure that we're factoring out the most that we can, and then we should be ready for the review and the test. Okay, so let's look at the steps we want to think of or we want to follow as we're solving these problems. Okay, so first step, so we always want to consider this, right? First step, check to see if there's a GCF. And keep in mind that you may not have a GCF to factor out. When does this happen, right? If I have a GCF of 1, then there might not be anything to factor out. And when we're factoring out the GCF, if we figure out what it is, remember we put the GCF in the front of the parentheses, and then we start dividing and seeing what we get, and we put that inside the parentheses. Okay, and keep in mind, if you do find a GCF, then the answer is not prime. Okay, if you do find a GCF and you take it out, then the answer is not prime. Keep that in mind. Okay, after you take out the GCF, then you want to check, and remember what I was doing last class, right? I was saying, can we do anything with the parentheses? Sorry, the parentheses. Can we apply one of these 4 options to the parentheses? So that's what we want to keep in mind when after we factor out the GCF, then we're left with this parentheses, and we want to check to see, is the parentheses a difference of 2 squares? Is it a perfect square trinomial? Can we use the table method? So remember this method here, I like to call it the table method. Can we use the table method on the parentheses? And if we see that we can't use any of the first 3, then we say none of these. Okay, but keep in mind, again, if you took out a GCF, then your answer is not prime. But if you didn't have a GCF and none of the methods that we've learned were used, and so you'd say none of these, if there is no GCF, then it's prime. Okay, so again, let me write that on the side. If you get no GCF and you didn't apply any of the rules, then we have a prime situation. So again, if you got no GCF, you got a GCF of 1, and none of the methods applied, then your answer is prime, because nothing could be done, right? Okay. All right, and then the last thing I want to talk about is oh, sorry, I forgot about step 3. Step 3 is just saying, if you do figure out it's one of these methods, apply the correct process that we've learned. And on the next page, we're going to summarize the processes again, but we've practiced it several times. We've practiced difference of 2 squares, perfect square trinomial, and the table method. Yeah, and then if you factored out a GCF, the result you got after factoring out the GCF is your answer. So if you only got to step 1 and you took out the GCF, then that's your answer. Okay, so let's look on the next page, the different processes that we've seen. Okay, so on this page, we have the summary of the difference of two squares. We have perfect square trinomial situations. We have the table method. So these are the main three that we've learned. Just a reminder about let's look at these two, the difference of two squares, the perfect square trinomial. Difference of two squares, it needs to be made up of two terms that are subtracting. Then it is a difference of two squares. Perfect square trinomial. There were two situations. You can have a plus situation, and that means that you have a plus in the parentheses. If you have a minus plus situation, then you have a minus in the parentheses. And then going back to the difference of two squares, if you have a subtraction, then keep in mind it's going to be a plus minus situation inside the parentheses. Okay, so that's kind of a summary on that page, on those methods. And the table method is the one where we multiply the first and the last term, and we try and figure out what two numbers multiply to give you the first times the last, and then those two numbers have to add up to give you the middle. Okay, and then there's two situations, right? If the first number is 1, or if it's not 1, then we have to divide. So we're going to be going over that as well. All right, so let's go ahead and jump into the examples. So let's look at example 1. Let's read the instructions, right? Factor the polynomials completely by filling in the blanks. If they cannot be factored, write prime. Remember that if you pull out a GCF, you have factored the polynomial, so it is not prime. All right. So let's factor out the GCF. Let's identify the GCF. So GCF is equal to, what number can divide 12 and 75? Looks like they can both be divided by 3. Do they have any A's in common? No, right? And is the first term negative? No. So then I'm just going to divide both the first and the last by 3. And then we're going to factor out the GCF. So put the GCF in front and parentheses. Okay. What is 12 divided by 3? It's 4. Bring over the a squared minus, and actually let me move this parentheses because I think I'm going to need space. There. What's 75 divided by 3? It's 25. Okay. Then we have what's in parentheses, right? This part right here. Can I do anything with that? Is this a specific type of situation? Well, it has two terms. Can I square root? Square root. Can I square root the first and the last, right? 4a squared and 25. That's 2a. And that's 5. Oh yeah, that's 5. Yes, so I can square root the first and the last. Is there subtraction happening? Yes. So then we got an A situation. It's a difference of 2 squares. And remember, this is like my A, and this is like my B. So I'm going to do A plus B times A minus B. And so it's going to be 2A plus 5 and 2A minus 5. And so again, keep in mind that this is only the orange section. So my final answer has to have the GCF in the front, right? So it has to have a 3 in front. So I'm going to put a 3 in front. So my final answer is going to be 3 parentheses 2A plus 5 parentheses 2A minus 5. Okay. Awesome. So let's go to the next one. Oh, just keep in mind, here I just put the type of method that I use, right? We use a difference of 2 squares. Okay, let's go to the next one. Example 2. Okay, let's see if we can find a GCF. It doesn't look like they have any numbers in common other than 1. Remember, there's a 1 in front here. It's not written. What about letters? How many x's do they have in common? They have 1 x in common. And is the first term negative? Yes. So I'm going to put a negative in the GCF. So I'm going to divide both of these by negative x. So parentheses. Okay, what's x squared divided by x? It's x. Remember that negative divided by negative is a positive. Positive divided by negative is a negative. And x divided by x is 1. So negative 1. Okay. Now, with what's left in parentheses, can I apply, one of these types? Well, it's not a difference of 2 squares because I can't square root x. It's not a perfect square trinomial because it needs to have 3 terms and it only has 1, 2, 1, 2. It's not a table method, so it looks like it's none of these. So I'm going to put D. It's D, none of these. And so there's no work to be shown other than what we did when we took out the GCF. So again, this is not a prime answer because we were able to take out the GCF. Okay, we were able to take out the GCF. So this is my answer. The answer that I got when I did the first process. Okay. All right, let's go to the next example. All right, so let's start off again. What is the GCF? What number can divide all of these 3 numbers? I can divide 4 and 14 by 2, but I can't divide 15 by 2. I can divide 15 by 3, but I can't divide 4 and 14 by 3. So it looks like it just has a GCF of 1. So we could say, there's really no GCF. So I'm just going to copy the original problem. And so this is what I'm wondering about, right? What can I do with this situation then? It has a GCF of 1, so there's really no GCF. It's not a difference of 2 squares because it doesn't have 2 terms. And this doesn't have 2 terms. Is it a perfect square trinomial? Can I square root the first and the last? So 4m squared is 2m. But what's the square root of the last one? What's the square root of 14? That's going to give me a decimal. So I can factor the first, but I cannot factor the second. Okay, so I'm going to erase that. I tried it out, it didn't work. So difference of 2 squares is not the perfect square trinomial, didn't work. So we got to try the table method. Okay, so let's make our table. We're multiplying and adding. And so we're going to multiply the first number and the last number. 4 times 14 is 56. And then the middle number is negative 15. So what 2 numbers multiply to give me 56, but when they add, give me negative 15? And so you should think of negative 7 and negative 8 give me positive 56, and negative 7 plus negative 8 is negative 15. Just extend these lines here. Okay, so then I got that answer. And so we would write the following parentheses. The letter is M and M. The numbers that worked were minus 7 and minus 8. But remember what we discussed last class is the number in the front a 1 or is it not 1, right? Is it different than 1? And we see the first number and it's a 4. So remember, we have to take that number and divide it. Divide it in the negative 7 and the negative 8 that we got. And simplify if you can. If you can't, then you leave it as it is. So I have m minus 7/4 because I can't divide, right? And I have m. Can I divide 8 by 4? Yes, that's 2. Okay, and then if there is a fraction left over, I need to take that denominator and put it up in front of the m, right? So it's going to be a 4m minus 7, and then just bring down the m minus 2. Okay, so my final answer is the last thing that I got there, 4m minus 7 and m minus 2. Oh, and I forgot to put what What method did we use? We used the table method, so I'm going to put C. We use C because we use the table method. All right. Let's go to example 4. Let's check to see if there a GCF. These terms don't have a common variable. Remember, there's a 1 in front of the y squared. If it's not written out, we assume there's a 1, and so there's no number that can divide all of these. So we have a GCF of 1, and so I can just copy the original problem because there was no GCF, and then we got to figure out, is this a difference of two squares, a perfect square, or a table method? Well, it's not a difference of two squares because it has 3 terms. 1, 2, 3. I forgot to mention this, but you can actually, cross out the options that don't work. So let's look at perfect square trinomial. Can I square root the first and the last? Yes and yes. And then I gotta check what's 2 times A times B. Remember, this is like my A, this is like my B. So what's 2 times Y times 6? That's 12Y. Does that match the number in the middle? Yes. So then that means that we're going to have 2 parentheses with A and B, and is it going to be plus plus or minus minus? So it depends on the situation. We have a minus plus situation, so that means I'm going to have a minus minus. So that's going to be y minus 6 and y minus 6. And actually that's my final answer. It's y minus 6, y minus 6. So the method that worked was B, perfect square trinomial. So this is a type of polynomial that we had because everything checked off, right? The square roots and the middle number matched. So we had a perfect square trinomial. We had a minus plus situation, so we did minus minus. So it's y minus 6, y minus 6. Okay, 2 more examples. Let's go to 5, number 5. So to start off, right, check for GCF. Is there a number that can divide 2, 11, and 9? The only one I can think of is 1. And do all the terms have an n? No. So the GCF is 1. So there's basically no GCF. So I'm just going to copy the problem and check to see what method do we have. Is it a difference of 2 squares? No, right? Because it has more than 2 terms. Is it a perfect square trinomial? Can I square root the first term? Can I square root n squared? Yes. But can I square root 2? No. So it's not a perfect square trinomial. So let me erase my work here. Okay, so let's try the table method. Let's make this table. Actually, let me put it over here. So we have times, we have plus. And so we're going to multiply the first number times the last. 2 times negative 9 is negative 18. And then the middle number is negative 11. So can we think of two numbers that multiply to give me negative 18? Actually, let's try the two numbers that we multiplied right now. Is 2 times negative 9 is negative 18. And what's 2 plus negative 9? That's negative 7. Okay. What if I switch the positive and the negative? Negative 2 and positive 9 gives me negative 18. But negative 2 plus 9 is 7. Nope. Right? Because I don't want to get 7s, I want to get 11. So those don't work. But then you might think, oh, what about negative 2 and negative 9? Because negative 2 plus negative 9 is negative 11. It worked, right? Well, be careful, because even though we got the middle number, what's a negative times a negative? That's positive 18. But do we want a positive 18 or negative? We want a negative 18. So that doesn't work. Okay. So the table method doesn't seem to work. I mean, you can try other multiplications for 18, right? 1 times 18, 6 times 3. But I don't think those other options will give you negative 11. So that leaves us with none of these. So D. So my GCF was 1. None of the methods worked. And so can this example be factored? No. Right? So again, if your GCF is 1 and none of the methods worked, then your answer is prime. So this example is prime. But make sure that you've checked every method. Because a lot of times students, they don't want to try all the methods, and so they say it's prime, but maybe it was a perfect square, or maybe it was the table method, but you didn't take the time to check. So take the time to check before you say that it's prime. All right, and then the last example, example 6. So again, we're going to start off and check to see if there's a GCF, right? Okay. Is there a number that can divide 2, 30, and 72? Looks like they're all divisible by 2. And it looks like the first number is negative, so I'm going to put negative 2. Now let's look at the variables. The letter is H. How many H's do they have in common? Looks like they have H squared, right? 2 H's in common. So that's my GCF. I'm going to divide all 3 by negative 2h squared. And I'm going to put the GCF in the front, negative 2h squared, and set up my parentheses. Okay. So negative divided by negative is positive. 2 divided by 2 is 1. H to the 4th divided by h squared is h squared. What's negative 30 divided by negative 2? It's positive 15. What's h to the 3rd divided by h squared? That's h. And then what's negative 72 divided by negative 2? Negative divided by negative is positive, so it's going to be positive 36. And then h squared divided by h squared cancels out. And so I have to check, remember what I have left in parentheses. Is it one of these methods? Okay, so is it a difference of 2 squares? It has 1, 2, 3 terms. So it's not a difference of 2 squares. Is it a perfect square trinomial? Is it a perfect square trinomial? Let's see. Can I square root the first and the last term? Can I square root h squared and 36? Yes and yes. So this is my A, this is my B. But remember, for perfect square trinomial, I have to check what is 2 times A times B. So what's 2 times H times 6? That's 12H. Does that match the middle term? Does that match the middle term? No. Okay, so then it's not a perfect square. It's not a perfect square, so I'm going to cross out option B. I'm going to erase my work for the perfect square because it wasn't a perfect square. Okay, so the next method, is it a table method situation? So we're going to multiply and add. And so we're going to multiply, if there's no number in front of h squared, then we assume that there's a 1 there. So we're going to multiply 1 times 36, which is 36. And the middle number is positive 15. Okay, so two numbers that multiply to give me 36. Nine times 4 is 36. What's 9 plus 4? That's 13. I don't want 13. What about 3 times 12? That's 36, and 3 plus 12 is 15. That works. So I'm going to set up my parentheses. The letter was H, right? The numbers that worked were positive 3 and positive 12. Okay, so the table method worked. So I'm going to say that the type of situation that I have is C. But remember, the answer that I got right here is just the part in parentheses. I still need to put the GCF in the front of this. So I'm going to put the GCF first in my answer. I'm going to put the GCF first in my answer. So I'm going to type, or not type, but write negative 2h squared. So remember at the very beginning, that was my GCF. And then I'm going to copy this orange part. So it's h plus 3 and h plus 12. And this is my final answer. All right, guys. So thank you for joining me on these notes. Like I mentioned again, next class after we cover these notes will be a review, and then after the review will be a test. But this lesson is a good lesson that covers everything that we've learned and what the test could look like, right? In the test, I'll give you a random problem to factor, all right, a random polynomial, and you have to decide, what method should I use? What's the GCF? And so just kind of using everything that we've kind of covered in this notes. But I'll see you in class next time, and then if you have any questions, you can ask me there. But have a great day, guys. Thank you.